Welcome back to the lecture 2 of part 3. We are going to talk about functions now. You may have come across them before in other languages, where they may have been called subroutines or procedures. Functions serve two primary development roles. They maximize the reusability of the code and minimize redundancy. The second role is procedural decomposition by splitting systems into pieces that have well-defined roles. Functions reduce our future work, and if the operation must be changed later, we only have to update one copy in the function, not many scattered copies of the code throughout in our program. In Python, def create a function object and assigns it to a name. Let's create a simple function. Say def func name, pass in some parameter param1 and print param1, and let's add another line of code, print param1 plus. This is Python. So let's run this code. Now we can call this function func name, like func name, pass in some string hi, and let's execute. Hi, this is Python. So what's going on? We are calling the function func name with an argument hi. It passes into param1 and then run the first line, which is hi only. When it comes to the second line here, it prints param1, which is hi. Then using plus, we are concatenating param1 and the string, this is Python. So it's printing hi, this is Python. So we can use default value of parameters as well. Like, let's define this function again. We can copy this one and paste it here. And instead of, we can pass in default value. And now run this code. Now if we call this function, now if we don't pass the parameter to the function, it will consider default value as its parameter. Let's run this code here. We have default value, which is param1, printed in the output from this statement, and from the second print statement, default value, this is Python. If we pass a parameter here, it will replace the default value, like we can say hi. Now this default value is replaced by hi, so it's printing hi, taking this past value and printing in the output. Let's create a function that takes two parameters and returns the multiplication of those two numbers. We can write a function, say define def myfunc, pass in num1 and num2, colon here, num equal to, we want to multiply num1 and num2, and we want the function to return the multiplication, which is num. Let's run this code, and now let's call the function myfunc, pass in two numbers, say 2 and 3, and run this code. So we have 6 in the output. So we are calling the function myfunc, passing 2 arguments, 2 for num1 and 3 for num2. It's multiplying and returning the result as num. Instead of writing these 2 lines, we can delete this one and simply return num1 and num2. This will be the same. So instead of writing 2-line code, we can simply return the multiplication of num1 and num2 in a single line. So the functions can have document strings as well, and the document strings are enclosed within double quotes. Let's take this function and add a document string here. This function is returning the multiplication of 2 numbers. Let's run this code. Now, what if we want to see this document string? In Jupyter Notebook, we can write myfunc and press Shift Tab. And when we press Shift Tab, Jupyter Notebook knows that the user is asking for document string. So this is the document string that we have written here. So we will commonly use Shift Tab method to see the document string for the built-in functions within the Python during this course. It's important to know that document strings are very useful, especially for built-in functions. For example, let's try for range. If we press Shift Tab, this is the document string for range. So now in this case, we don't need to memorize this all. We will be using this feature lots of time in the course at the later stage. This was all about the functions. Let's move on to the lambda expression. The lambda expression is a way to create small anonymous function that is a function without a name. These are throwaway functions and created when we need them. Lambda expressions are mainly used in combination of filter and map functions, which are built-in methods in Python. Journal syntax for lambda expression is lambda, a keyword, and then argument lists, followed by colon, and then expression. The argument list consists of comma-separated list of arguments that we pass in. The expression is an arithmetic expression using these arguments. We can assign lambda expression to a variable to give it a name. Let's write a function which returns square of the number and then rewrite that function to lambda expression. So let's add a couple of lines here. So def square num return num square. Let's run this code and then call the function square 4. We have 16 in the output. We can write the same function in a single line like this and call it again. So it's doing the same job. Now to write the lambda expression for this functions, we have to follow the following steps. Let's copy this thing here and paste it in the new cell. Replace def with lambda. Then delete the name of the function, which is square. Remove these parentheses and then delete return. So this is easy. Now we have transformed this function into a lambda expression. We have replaced def with lambda, deleted the name of the function, and removed these parentheses, and then removed return. Let's run this. So we have something func main lambda. Hold on. We will use this expression in map and filter to understand in detail how the lambda work. Let's learn map and filter now. So we have seen that we can calculate the squares of numbers in a list using a for loop. So to do this, we need to follow the following steps. Let's move on and see where we did this before. Like here, create an empty list, iterate over the list x here, and then append the square of each number in x to the empty list, and then print the value at the end. This is a tedious process. This is where map plays its role. Let's try to do this above task again using a for loop. I have x equal to 1, 2, 3, 4, and 5. I create an empty list y equal to empty list. Now in a for loop num in x colon, and then append the value of num square to an empty list y, and print y. So I have 1, 4, 9, 16, and 25, the square of these numbers within x. Map is a function with two arguments, a function and a sequence. For example, list. It maps a function to every element in a sequence. We have recently created a function square. Let's pass in square and x to map, and result equal to map square x, and run this code. Let's see how the result look like now. So we have to pass this result into a list to get output. So 1, 4, 9, 16, 25, the same one what we are getting from this for loop. So using map with square and passing in the list of numbers, we are getting the same output. Lambda works great with map. For example, we don't need to write this function square. This is a one-time use only. It's better to use lambda for this purpose. Let's try to write the same code using lambda expression. So we have map, we pass in lambda num. We can copy this one actually, because this is our lambda expression for square. So our first expression and our second expression is x. So instead of passing square, we are writing lambda expression here. So instead of passing square, we are writing lambda expression here, and we are passing x, the second argument. And we need to wrap it into a list so that we can get output. This is the same one. So this whole function in a single line, where we don't need to create square, we are using lambda expression for square, and then passing in the x, which is the list of those numbers that we want to calculate squares for. Map can be applied to more than one lists as well. Let's say we have three lists A, 1, 2, 3, 4, B, say 17, 12, 11, 10, and C, say -1, -4, 5, and 9. So let's copy this code here. And if we want to add these three lists, let's pass in X, Y, and Z. And what we want to do, X plus Y plus Z. And what are our lists? Our lists are A, B, and C. So we have X, Y, Z from each list, and we want to add those X, Y, and Z. And what are our lists? A, B, and C. This is our lambda expressions to add these lists at each index, and A, B, C are our lists. Let's print this one. So we have 17, 10, 19, 23. 1 plus 17 minus 1 is 17. 2 plus 12 minus 4 is 10. 3 plus 11 plus 5 is 19, and so on. So this was all about map at the moment. Let's move on to the filter. Filter is another very useful built-in function and provides an elegant and smarter way of filtering out the elements in the provided list, for which filter returns true. Filter takes two arguments, a function or lambda expression, and a list. This is same as map. First argument returns Boolean value, true or false. The function, which is argument 1, will be applied to every element of the list, which is argument 2. If the function, which is actually the argument 1 or the lambda expression, returns true, for the element in list, which is our argument 2, the element will be included in the resulted list. For example, let's filter out even numbers from 0 to 10. We can use a range here as well. Let's write a lambda expression first. Lambda num. We can use mod operator, mod 2 equal to 0. This is our function, and range we want between 1 and 10. Let's put this lambda expression and the range argument in filter, and then let's pass into the list so we can get output. Here it is. So this is our lambda expression or function as an argument 1 for filter. Range 1 to 10 is the argument 2 for filter, which is a generator for the numbers. If the lambda expression is true for the number in range, it will include in the list. 2 returns 0, 4 returns 0, 6 returns 0, and 8 returns 0, and the filter is returning the numbers where the lambda expression is true. So this was all about filter, guys. I hope now you have a better understanding on functions, lambda expressions, filter, and maps, along with other key concepts. We are done with Python Essential section. It's time to do some practice. In the next lecture, we will have a quick overview on the Python Essential exercise. It's a good idea to try them out first. However, after that, we will discuss the solutions as well. So see you in the next lecture. Good luck.